Good morning. Um, so, as I informed in my email, today we will be having a discussion class, and the discussion will be conducted by Mr. Bandara. So, I think we already have the access to the problem set. It is in the chat as well as it should be in your email. Mr. Bandara.
Hi, Dr. Sangyat. I am here.
Okay, good.
I hope you can hear me.
Yes, at least I can hear you. Students.
Okay. Dear student, please give me 1 2 minutes. Now I am preparing for the writing pad, right? So please give me 2 minutes, right? Okay.
Okay, very good morning, all of you. I hope you all can hear me. And again, I hope you can visualize the things what I shared on my videos, right? Is it okay? Audible and videoable? Okay, right. Thank you. Right. Okay. Yeah, Dr. Chaturanga is not available today, so I have the duty to cover some assignments. I hope you all can receive it, right? Those problems are created according to what you learned on the previous week, right? So we can discuss the problems one by one with some important theory parts. Then you can recall the things what you learned, right? So these are very simple things, right? Right? But I hope you all can do me well with me, or you can carefully look at me. Sound is not clear. So, okay, now I am in an empty room, right? I think there will be some echo. Yeah, give 1 minute. So how about now? You can hear me clearly now? Okay, that's the nature, right? Someone here, someone not, right? So, okay, thank you. So we will go for the question number 1 of assignment 1, right? Question number 1 of assignment 1, right? Actually, it's a quadratic equation. So we need to know how to solve the quadratic equations. As normally, the quadratic equation like this, right? Solving quadratic equation means we need to find which x are satisfy these equations, right? Which x are satisfy this equation, right? So normally we can find the root of any quadratic equation by the formula the x equal. These are the x satisfy this equation. That's mean we have to find the 2x because this is quadratic. There will be two values for x satisfy this equation. Those values we can find by this equation. This is a standard equation to find the root of quadratic equation. So minus b plus or minus b squared minus 4ac divided by 2a. Voice is repeating, right? Yes, because of this, I think there will be some echo in this room. So this is the place I have to do the session, right? So I'll speak slowly, separate by words, right? Please manage, right? So Okay. So, and one thing, can you see my writing clearly? How about that one? Can you send some? Okay, thank you. Thank you for your reply, right? By using this formula, we can find the roots of this quadratic equation, the which x are satisfy the equation, right? So, I think you all already know there are three types of solutions we can find for this quadratic equation. It's depend on the things inside this square root. The things inside on square root is b squared minus 4ac. We call this discriminant of equation. Discriminant. Right? The discriminant of the equation. The roots of x1 and x2 depend on this discriminant. I know you already learned about inequalities. The greater than or equal, less than, and less than or equal. I think you already learned those inequality signs, right? Now, the discriminant of this equation is greater than 0. That means the things inside this square root is positive. Right? Is greater than 0 means this part is positive. So we can say this quadratic equation has two distinct, it means two separate things, right? So two distinct real values. Real values. Normally we call the real is like this. R, right? If the discriminant is greater than 0, the quadratic equation has two distinct real values. Two distinct, right? The separate, different, two different real values. Real values, right? The next condition is if discriminant equals 0. So whatever the things available inside this square root is equal 0, we can say it has two equal roots. Two equal roots. X1 equal x2, right? There's a two equal roots, right? We call that as a two equal roots. It means the roots are equal. The both of these roots are satisfied the quadratic equation. Then third condition is b squared minus 4ac less than c. It means this part is negative. Discriminant is negative, right? Now we should be tricky, right? Whatever the things inside the square root, this x should be positive. The positive x values, we can define the square root x. But here we got the b discriminant is negative. Something inside the square root is negative, we call that value should be in complex. Right? I don't know you whether learn or not this, but focus what happened when the discriminant is negative. We have the two complex root. It means we normally say the minus square root of -1 is I. Right? The complex number we define as Z equal X plus IY time, right? Don't go further, those things, right? Things on this part, if B squared minus AC is negative, it has two complex roots, right? We never, I think, the empty 100, this empty 1000 to course is not expect this much of things, but I here explain how the root of the quadratic equation depend on this discriminant. There's three types of roots we can find for the quadratic equation. Two distinct real roots, this one, or the two equal roots, or two complex roots. That's the theory behind the how to solve the quadratic equation, right? So we move for the first section, right? First section, part A. It's given the quadratic equation 4x squared minus 19x plus 14 equals 0. First class, when we see the quadratic equation, observe the values in front of x, squared x and the constant term. If we can create the middle term by using the coefficients of x squared and the constant, we no need to go for the equation. That equation means x squared minus b plus or minus b squared minus 4ac 2a. If we can create the middle term, that means the coefficient of x by using the coefficient of x squared and the constant term, we can factor out, we can find the roots of this quadratic equation easily. If someone is doubt on this, and if you have the calculator, then directly you can go for this equation, right? So b equal minus 19, a equal 4, c equal 15. By substituting these values to this equation, you can easily find x1 and x2, right? So here we can create 19 minus 19 by using 4 and 15 like this, right? 4x squared minus 4x minus 15x plus 15. Now minus 19x I create by using 4 and 15. Now this is equal 0. Right? Is it harm for the original equation? No, there's no any additional things to do for the equation. Both the equations are same. Minus 4 minus 15 is minus 19. There's no any harm for the original one. There's only creation for finding the roots of the x, right? Now we can combine 2 by 2. I take out the common factor of this one. The common factor is 4x from these two. Then inside x minus 1, considering these two, 4x squared minus 4x, common factor is 4x, right? When you take out the 4x from these two, the inside it's received rest x minus 1. From this part, the common factor is 15. I take the minus 15, x minus 1. Are you clear about this place? This is a very simple thing, right? Factor, how to factor, right? By considering these two terms, the x minus 1 is common factor. We take out the x minus 1, the rest 4x from the first term minus 15 from the second. Right. The two factors are the multiplication of two terms equals 0. Now we can say this part may be 0 or 4x minus 15 can be 0. right? Now we are end of the question, right? So we can this part we can say x equal 1 or 4x equal 15. Now x equal 15 no. So this quadratic equation has two distinct real values. The roots are x equal 1 and x equal 15. The both of these values satisfy the equation, right? Both of these roots are satisfied the equation. Now, this is the way we solve the quadratic equation. We didn't use the formula. By observing the coefficients of the variable, we can create the middle term by using coefficient of x squared and the constant term. Right? I hope you all can clear. When you move to the second part of the equation, the first question is from that equation we cannot see the quadratic equation, but this equation is like this. The equation like this, right? They have a numerator, denominator, right? So, now we have to find which x are satisfied this equation, right? So what we have to do, now we are going to create this one without discriminant, without denominators. We are going to remove the how we remove the denominators? Consider the check left hand side.
Can you hear me? Hello. How about now? Can you hear me? Okay, good. Right. Something happened, right? Okay. So the first part you multiply x minus 2, x minus 5, this one. Then plus x minus 2, x minus 5 times x of x minus 2 equal x minus 2, x minus 5 times 3 over x minus 2 is 5. Right. So the denominators can't be 0. It means 1 over 0 is not defined. Therefore, the denominators cannot be 0. Therefore, x minus 5 cannot be 0, x minus 2 cannot be 0. Therefore, we can remove this one. We can remove the common things on numerator and denominator. The x minus 2 is here. Then the right side, the both part we can remove. Now, the x minus 2 plus x times x minus 5 equal 3. Equal 3. No, not 3. Yes, it's 3. Right? So we can remove the brackets up to, we can simplify this one, x minus 2 plus, we can multiply the terms inside the bracket by using the outside term, x square plus x minus 5x minus 5x equal 3. Then we can rearrange it like a quadratic equation, x square, this part minus 4x. Then we take 3 to the left side, minus 2. When it become to the left side, it's become minus 3 equals 0. Now it is equal x squared minus 4x minus 5 equal 0. You got it? Now this look like the quadratic equation. Right? Now this one is look like quadratic equation. Now we can find the solution for this quadratic equation. Which x are satisfied the quadratic equation? The first part means, right? Yeah, the one is to ask to go for the first part. Your first part is this one. I think how to remove the denominator. So the given equation is not look like good, right? It's not look like a quadratic equation. Now we have to find the value for x. We have to find the value for x, but x is in the denominator. In Sinhala we call it hare, right? It's on the denominator. If we can remove the denominator, we can get this x values from numerator to numerator, then we can easily solve. If we solve the equation like this, what we have to do, we have to find the common, we should multiply the whole parts by the common term. That common term, when we multiply it by the common term, it should remove the denominators of each terms. By observing the two sides, the denominators are x minus 5 and x minus 2. When you observe the denominator of the right side, the same things x minus 2 and x minus 5. When you multiply the both sides by using x minus 5 and x minus 2, we can remove the denominators of each and every term. For that, here I write the whole part, right? The first part, 1 over x minus 5, 1 over x minus 5, multiplied by x minus 2 times x minus 5. Then we can cut down the x minus 5 from here. We multiply x minus 2, x minus 5 by the second term, x over x minus 2. Then we can remove the x minus 2 terms. The right side, we multiply right side by the x minus 2 and x minus 5. The multiply factor and the denominator of the right side terms are same. We can remove the both. After removing the common things in the up and down, The rest part we create this one x minus 2, x times x minus 5 equal 3. When you simplify this one by taking the common terms to the closer, then x minus 2 plus x squared minus 5x equal 3. Then we rearrange this look like the quadratic equation x squared. Then x and minus is minus 4x. Minus 2 times when it become 3 to the left side, it's become minus 3, minus 2, minus 3. Now the quadratic equation become like this. This is a formal quadratic equation, as usual, formal quadratic equation. Now we can, thank you, yes. Now we can solve this quadratic equation by using that equation, or we can observe the terms, and we can rearrange it. Now by using the constant term and the coefficient of x squared, we can create this one, the 4x. Can you create it? Yes, we can, right? Like this, x squared. Now I am going to create this minus 4x by using the constant term 5 and the coefficient of x squared. The coefficient of x squared is 1, right? How we create this one? Minus x plus 5x minus 5. Is it? Minus x, no, plus x minus 5x. I cut it. I write this down, right? I bring that equation to the other side. X square, our quadratic equation is 4x minus 5 equals 0. No? Now, minus 5 and 1. By using minus 5 and 1, we should create the minus 4x like this. X square plus x minus 5x minus 5 equals 0. Is it? Now we consider two terms. By considering the first two terms, the common factor is x inside x plus 1. Then we take the minus 5 as the common factor of rest terms. We take the minus 5 outside, inside x plus 1 equals 0. Now consider these two parts, the common factor is 1. The rest x minus 5 equals 0. You all clear? Very simple thing, right? I hope you all got it. Right? Now the two terms equal 0, we can say x plus 1 equals 0 or x minus 5 equals 0. This part can be 0, this part can be 0, the both can be 0. By solving this one, we can say x equal minus 1, or by solving this one, x equal 5. The roots are x equal minus 1 and x equal 5. Minus 1 satisfy this equation or 5 satisfy this equation. Right? This is the answer for question 1 part 2. Right? Anything doubt on that? Very simple, right? It's a very simple thing. How to solve the quadratic equation. Right? There will be two types of way we discuss how to solve the quadratic equation. The first, without wasting time, you first directly you can apply the equation x squared x equal minus b plus or minus b squared minus 4ac divided by 2a, right? All of the we can identify what is the a of the equation, what's the b of the equation, what's the c of the equation. A is the coefficient of x squared, b is coefficient of b, so coefficient of x, the c is the constant term. So otherwise, when you observe the quadratic equation, try to build the middle term. The middle term means the x term. by using the coefficient of x squared and the constant term. If we can create the middle term by using the coefficient of x squared and the constant, we no need to apply the equation what we have for the solve the quadratic equation, right? Okay. The second question is the inequality, right? The second question is the inequality. How to solve the inequality, right? How to solve the inequality? The inequality has two sides, left and right. The left side is some variable. We have to find the which x when I write the first one. What's it called? 2x plus 1 x squared minus 4 greater than x. So this is the first part. So what we have to do, now we find the range which x are satisfied this one. So solving inequalities mean which x values are satisfied this equation. That's mean when we substitute one x for this places, this side should be the greater than 0. Yes.
This meeting is being recorded.
From the previous one, the x minus 5, so the x equal 5, we cannot be. Thank you very much for remembering that, right? X equal 5 cannot be the root because when x equal 5, the equation is undefined because x equal 5 means this part getting 0. Right? So the roots, as a root, we can consider as x equal minus 1 of this one, right? This quadratic equation. Right? Now, when you are focusing this, okay, now for the inequality, solving inequality means we have to find the which x are satisfy this inequality. The left side greater than 0. When I substitute the x value for these places, it should give the positive value. It should give the positive value. Now, solving this inequality means we have to find the which x are satisfy this condition. For checking the which x are satisfying this condition, we have to find points. Which x point should be here? For that, we consider this inequality as equality. We consider this as equal up to find the critical points, right? So 2x plus 1, the x squared minus 4, we can rewrite the 4 as the perfect square, minus 2 square equals 0. Now 2x plus 1, this is the difference of 2 square. Difference of 2 square, x minus 2 and x plus 2. I hope you know how to factor out difference of 2 square. If a squared minus b squared, difference of 2 squares equal, the factors are a plus b and a minus b. Right? A plus b and a minus. By using this one, we can factor out x squared minus 2 squared. Now we can find the values 2x plus 1 equals 0 or x minus 2 equals 0 or x plus 2 equals 0. Now we can find the value for x. From this one we can get the x equal minus 1 over 2. From this one we get the x equal 2. From the rest one we get the x equal minus 2. Now we got the 3 points. Now we got the 3 points, right? Now what we have to do, we should place these 3 values on the timeline, on the real line, not the timeline, right? This is the line, the real axis. Now we are going to place the previous 3 values, what we got from this equation on here, right? Here is minus half and minus 2. The first one is minus 2. The next one is minus half, then plus 2. Now we have the, how many sides we have to check these inequalities? We have this part. The x values we can get from left side of the minus 2. For this inequality, what's the inequality? 2x plus 1 x squared minus 4. Or we can write it as 2x plus 1 x minus 2 x plus 2 greater than 0. For checking the which x are satisfied this inequality, now we have the 4 regions. The left side of the minus 2, the side in between minus 2 and minus half, the interval between minus half and 2, then 2 to infinity. This part is minus 2 to minus infinity. Now when we pick the element from this 4 side, one by one, we have to check which values make the positive value of this side. Right? As an example, we can consider test point. Right? Now we can get the test point. I renamed my area as 1, 2, 3, and 4. Actually, when you are doing this type of questions on your exam paper, no need to this type of explanation, right? Now here I do these things for getting understand you, right? When you are doing this type of problems, then you automatically you may know how to do it, right? For this explanation for getting easily understand how to do this one, right? When we consider the first region, my test point is any value from minus 2 to minus infinity. I take minus 3. My test point is minus 3 from first region. When I substitute minus 3 to here, now I am going to check the sign of these 3 terms. Sign. Whether it's plus or minus. What about 2x plus 1 when we substitute x equal minus 3? It's minus 3 plus 1 minus 5. It's a negative. Then minus, when I substitute the minus 3 for the x minus 2, it's again minus. When I substitute the minus 3 for the x on x plus 2 terms, it's become minus. This all is minus, right? Can we take the x value for satisfying this inequality from the region 1? We cannot, right? Because this inequality is getting negative, its mean not is positive value. It's a greater than 0 mean the left side should be the positive. Now, when you take the test point from the region 1, it is a negative value. We cannot get this region as the best region for satisfying this inequality. When you consider the second region, my test point is -1. My test point is -1 because -1 in between -half and -2. Substitute -1 for this equation. When you substitute here, -4 plus 1 -3 is negative. The middle term is already negative. When you substitute the -1 for the x plus 2, it's become positive. Minus minus is positive. Positive times positive is become positive. For this region is okay for satisfying this inequality. Left side is positive. When you go for the third region, take the 0. The test point is very simple, very easy one. This is 0. 0 is in between -half and 2. Right? When you substitute 0, the first term is positive, the second term is negative, the third term is yes, definitely. We should get the mark for this one, right? The third part is become positive. Right? Now, positive minus positive is become negative. This is not the perfect region for satisfying this inequality. Right? When you go for the fourth region, take any number from 2 to infinity. I consider 4 is as my test point. 4x, substitute x as 4 for this inequality, the places which have the x. First one is positive. When you substitute x to the 2x plus 1 is positive. When x equal 4 is positive. When x equal 4 from the last term, x plus 2 part is already positive. This become positive. This is so. Right? Among these 4 regions, we got the 2 regions are satisfied this inequality. The second region is what? The second region in between -2 and -half. We can write -2 -half. The region is like it. The fourth region is 2 into infinity. 2 into infinity. Among these two, we can say the solution, the region which are satisfied the given inequality is -2 -half union of 2 infinity. This is the answer, the region which satisfied the inequalities. -2, the region in between -2 and -half, and 2 to infinities is the region satisfied the inequalities. Definitely you may get the marks for this one, right? There's no any failure. This is a correct method, right? Correct method. Right? When you go for the next one, that one is little bit tricky, right? It has a numerator and denominator. X minus 4 divided by x4 minus 9x squared greater than or equal 0. Right? Now we should focus the denominator. Why? We have to remove the terms the which x values is affect for the undefined of this part, right? For that, I check like this. I am going to simplify the numerator, so denominator x minus 4. X squared is a common factor. I take out, then x squared minus 9. X minus 4, x squared, 9 we can write as perfect square root of 3. Then we can factor out again x minus 4, x x minus 3 and x plus 3. Right? Our critical points are, what's the critical point? X can't be 0. X cannot be 0. When x becomes 0, is short methods to find the regions. Plus minus after the side of region. I think you catch this method because of this part is sequentially change, minus plus, minus plus. I think because of the raise this problem, right? The region 1 is negative, region 2 is positive, again region 3 is negative, the region 4 is positive, right? This equally change, right? But the sometime we cannot see like this pattern. I think you may see the but you cannot catch it because this is a now this part has a pattern, negative, minus plus, minus plus, right there. When we are checking the some regions, we cannot go for like the pattern like this. Right? Same sign become the closer. Right? So because of this pattern, you may see there be easy way, but I prefer to you for using this, find the sign of the inequalities by using the test point. This is a very fundamental. There's no any steps to get in the wrong answers. It's very easy. Okay. Thank you. Now our critical point is the denominator cannot be 0. So our critical point is x equals 0, then x equals 3, and x equals minus 3. These points cannot be. Therefore, these are the critical points. We no need to focus this x minus 4. Right? Now our inequality is x minus 4 divided by x, x minus 3, x plus 3, greater than or equals 0. I place the critical points on the real line. Critical points on the real line. X equals 0, x equal minus 3, x equal plus 3. Right? We have the 4 regions. Now we can see which region is satisfied this inequality. Right? Which region is satisfied the inequality? May I keep this one for you? I do the region 1. My test point is minus 4. My test point is minus 4. Check the sign of this numerator and the denominator. The numerator is already minus. Here minus, here minus, minus, here minus. Right? What happened? When you take the minus 4 as the region from minus 3 to minus infinity, from the numerator is already negative. This x is negative, x minus 3 when x is minus 4 is negative, x plus 3 is when x equal minus 4 is negative. Negative, negative. This side is negative and negative. So should the first term of Yes, thank you. Yeah, it's x squared, right? Yes, it's x squared. Yes, x squared, right? So this part is negative, negative divided by negative is positive, right? So from the region 1 is the positive. When you go for the region 2, go for the point -1. So how do we decide the middle number in middle number? What's the mean the middle number? And one thing, 0, yes. Now here, we find the critical points as the 0 here. Now x square, x minus 3, x plus 3. For exist of this inequality, මේ inequality के පැවැත්ම සඳහා for exist of this inequality, denominator cannot be 0. හරය බිඳුව වෙන්න බෑ. Yes, yes, yes. Now I got right. Now I got yes. This one is positive. Yes. So yes, I'll explain it. Right. For existence of this inequality, the denominator cannot be the 0. We simplify the denominator up to find the critical points. When we consider these points, x cannot be 0, x cannot be plus 3, x cannot be minus 3. When it x equals 0, the denominator goes to 0. The inequality does not exist. So 0 cannot be here, minus 3 cannot be here, plus 3 cannot be here. Now in the region 1, I take the minus 4. When minus 4 x squared is plus, thank you. When minus 4 in substitute x minus 3 is the negative. Minus 4 substitute x plus 3 is already negative. What? How did we get the minus out? Why? There be a, from the previous one, there be a factor is 2x plus 1 now. Now this part is not critical points. Now these are the factors. Now we have to clearly identify the which areas we should divide the real line. For making the regions, we find the zeros of x. When consider this one, we got the x equal minus half. Now here, when we substitute this one to x0, the x equal to this one x minus 2. Because of this, find the zeros of x. Otherwise, how we find the regions without solving this one? For the inequalities, right? For solving inequalities, the main thing is what they expect. What are the regions of the real line satisfy the inequality? The inequality says this one should be greater than 0. Now I mean first one, right? 2x plus 1, x squared minus 4, which x values make the inequalities true. For checking that, we have to find the zeros of x. Because this one, there's no any denominator. We simplify the existing part, then find the zeros. The zeros of this one is x equal minus half, and x equal 2, and x equal minus 2. Now we have the 3 points. We can divide real line into regions by using these 3 points, the zeros of x. This one, the second inequality, it has the denominator. For existence of this inequalities, denominator cannot be 0. Yes, now I have explained this one, right? Now existence of the inequality, the denominator cannot be zero. Denominator cannot be the zero. I simplify the denominator. The critical point is x equals 0, x equals to x equal minus 3. It means when you find the region for satisfy these inequalities, on that region can't be exist 0, 3 and minus 3. 0, 3, minus 3, නැති regions තමයි මේක satisfy කරන්නේ. Without 0, 3 and minus 3. When we are considering the +4 is not affect for this one. When x equal +4, the numerator is 0, the inequality is greater than or equal 0. The equal part is satisfied. The critical points may affect for the denominator. The denominator cannot be 0. That's the main thing. Right? So we no need to focus this one. But the previous one, there is no any denominator or the numerator. We have to find the zeros of the equation. Zeros of the inequality. You got it? Right. Now the region 1. Now the region 1, I consider test point is -4. Then make x equal 4 දැම්ම කියලා මේ inequality ගැටලුවක් වෙන්නේ නැහැ. උඩ පාට විතරනේ බිඳුව වෙන්නේ. When, right? When substitute x equal 4, this inequality, there's no any effect for the inequality, right? The 0 or something. This can be. Main thing is denominator cannot be 0. The one student asked, why 0, 3 and minus 3 cannot be test point? When you substitute x equals 0, denominator getting 0. When you substitute the 3, denominator getting 0. When you substitute minus 3, denominator is 0. Right? Something divided by 0 is undefined. Then again we ask, why 1, 3 and minus 3? 1 in between 0 and, 1 in between 1 and 3. 1 is here. Again, when we consider test point as 3 and minus 3, denominator getting 0. මේක මේ හරය පවතින්න බෑ. හරය 0 වෙන points තමයි 0.3 ඉරණ 3යි. එතන ඒ තුන නැතුව තමයි අපි මේ inequality satisfy වෙන areas වෙන්නේ. Right? So that's enough time, right? Now we are in second point, right? So yes. When you consider the region 1 as -4 is our test point, substitute the numerator is negative, then x squared is a positive. The x minus 3 when substitute x equal -4 is negative. X plus 3 is again negative. Right? Negative is simplified. Negative divided by plus. It's a negative. Right? This whole part is getting negative. This is less than 0. So this region cannot be exist x values for satisfy this inequalities. When I go for the region 2, get the -1. Numerator is negative. So denominator x squared is positive. X minus 3 is negative. X plus 3 is positive. Positive. This become positive. This region can. Right? This is a greater than 0. Then region 3 and region 4 is up to you. Right? How we write the region 2? Region 2, we can write -3 and 0. Final answer I write here, you have to check the region 3 and region 4 by getting the test point from region 3. You can get any point from 0 and +3 as 1. Test point is +1. From 3 to infinity is +5. You can check, right? The final answer is here, right? -3, 0, union 0, 3, union 3, infinity. These are the three regions satisfy this inequality, right? I hope you all got the clear cut about this one because we spend more time for the inequalities. Yeah, I know some students may get some doubt about inequalities, right? When you do some fractions, you can clearly get how to solve the inequality. The normal inequalities mean the solving inequality mean which areas satisfy the inequality. We have to find the which area satisfy the given inequalities. Shall we move on? Section 3 is find the equation of the lines with the given properties. The equation of line. For equation of line. For find the equation of the line, we need 2 points. If you want to create the line, okay, this is the answer. -3, 0, union 0, 3, union 3 to infinity. This is the answer for the previous one, right? Okay. To find the equation of the straight line, we need to know known value, 2 known values, A, B, C, D. If we know the 2 points, exact 2 points of this line, through the line, then we can find the equation of this line. We pick random point as x, y on this line. We can create the slope of the equation. So slope of the line, or we call the gradient. Gradient of the line by using these known values. And again, we can write the gradients by using x, y and the one existing value. Right? The gradient from 2 different ways we can find. And one important thing is throughout this line, the gradient is same. So first we can find the gradient by using a known values. This A, B, C, D are the known values. D minus B. The gradient is for slope of the equation, slope of the line. Y divided by X. Delta Y divided by delta X. Right? Difference of Y divided by difference of X. Difference of Y of this point, A, B and C, D is D minus B divided by C minus A. Also, we can write the gradient of this equation by using x, y and a, b. Then y minus b divided by x minus a. Throughout the line, radius is same. So we can go for the equation by equal these two parts, y minus b, x minus a, equal d minus b, c minus a. When we simplify this one as y equal mx plus c, so this is the equation of the line. M is the gradient, c is the intercept, right? So we focus, this is a theory behind how to find the equation of the line. Now focus first one. There be a line L1 going through 0, 2 and minus 3, 6. This no worry about the Cartesian plan, right? I just write like this, but minus 3 is the other side of the 0. Don't consider about that one. Just write the 2 points on the line, right? Now we have to find the gradient of this. Sorry, we have to find the equation of this line through the gradient. I take one random point is x, y on this line. So apply this method. Gradient from two methods. First, I consider this one and this. Y minus 2 divided by x minus 0 equal. Now the gradient by using the known values. 6 minus 2, 0 minus 3. Right? 0 minus 3. Six minus 2. 6 minus 7. You should change the other side. 6 minus 2, then minus 3 minus 0. Right? So I write it other way. It's wrong, right? Same direction we should write. 6 minus 2, 6 minus 2, minus 3 minus 0. Right? Now, y minus 2 divided by x equal 4 divided by 3 is a minus. Then y minus 2 equal minus 4 over 3 times x. So our equation is y equal minus 4 over 3 x plus 2. The gradient of L1 is minus 4 over 3. Intercept is 2. So this is the equation of L1. Right? Equation of L1. The second one is asked L2 passing through the points A, it means 0, 2 and perpendicular to L1. Now this is the L1 equal L1 is equation y equal minus 4 over 3 times x plus 2. Where x is the L2 is going to 0, 2 and perpendicular to L1. This is a perpendicular. This is L2. Now we already know the one known points to the L2. For write the equation of L2, we need to know the gradient. Gradient of L2. But we already know just 1 point. From the previous one to find the equation of L2, we had the two known values. By using those two known values, we can find the gradient of the line easily. But here, it's difficult. Do you know the way for how to find the gradient of L2? I think you already know. If the two lines are perpendicular, the gradient of this line is M1 and the gradient of L2. Yes, nice. So there we one the equation of L1 is this. Y equal this. Y equal minus 4 over 3x plus 2. So if two lines are perpendicular, the gradients, multiplication of gradients equal minus. By using this, the gradient of L1 is ML1 equal minus 4 over 3. So ML1 time ML2 equal minus 1. ML1 is minus 4 over 3 time ML2 minus 1. So gradient of L2 equal 3 over 4. Now we know the gradient of L2. Now we can write the equation by picking random points as x comma y, right? So y minus 2 divided by x minus 0 equal the gradient 3 over 4. So y minus 2 equal 3 over 4 times x. So y equal 3 over 4 x plus 2. This is the equation of L2, right? Now third part, there will be a point line L3. L3 passing through the point B. Now B is here. Here point A, point B, and parallel to L2. This one is L2, is parallel. It's parallel. This is L3 going through minus 3 comma 6. L3 is parallel to L2 means L3 is perpendicular to L1. Yes. If two lines are parallel, M1 equal the gradient of two lines are same. Right? I pick the random point from here, x comma y. Now we already know the gradient of ML3 equal what? 3 over 4. Or we can go for the other method, right? By closing this one, L3 and L1 are perpendicular. By applying this one, we can find the gradient of L3. By considering the random points x comma y, we can write y minus 6 x minus minus 3 equal 3 over 4. Y minus 6 equal 3 over 4 times x plus 3. Y equal 3 over 4x plus 9 over 4 plus 6. You can simplify this one. So y equal 3 over 4 x plus blah blah blah, right? What? 33 over 4. This is the equation of L3, right? L1 perpendicular line is L2. The parallel line to L2 is this one. I call YL2, YL3. Right? Very simple, right? Find the equation of the lines. Solve the question 3. Right? I hope this is a very simple one. Okay? Right. Section number 4. So, charge, right? This is a piecewise function. Piecewise function, right? Piecewise function means how the functions behave on the different region. As example, I consider this is the real life. We divide the region 3 regions. This real line I divide to 3 regions. Right? There be a one function behave on this region as like this. Negative part. And this place is like this. On this area, it's like this. This is a piecewise function. The function behave in 3 different ways in different areas. As like us. Repeat last one mean what do you mean? You want to see this one? A parallel one, yes. When the two lines are parallel, the gradient of two lines are equal. The question says L2 and L3 are parallel. L2 and L3 are parallel. So we can find gradient of L2 by L3 by using L2. Because these are parallel, the gradients are equal. Right? So if gradient is equal to L2, now gradient of L3 is same, 3 over 4. Now 3 over 4 we can rewrite as, by considering the random points of the L3 is x comma y minus 6, x minus 3, that's the gradient is equal 3 over 4. Right? Do you know? Right, that's enough. Okay, this is simple. Okay, right. Piecewise function. The functions behave in 3 different ways according to the my regions. Okay, welcome. Right? This is a piecewise function as us. Right? It's like us. Okay. When we are at home, we behave in different way. Right? When we are at home, when we are stay with our parents, our behaviors are different. When you move out with our friends, our behaviors. Okay. When we go with our spouse, how is our behavior? So nice. Right? When we have become to university, our behavior is totally different. It's not like that. In our life function, our life function, born to death, is also the piecewise function. In our childhood, our behaviors and our things are different. When we become the kids, then school children, then after that, then university, when you got the married as a husband or wife, then it become the kids as a father or mother, and then finally they become the grandkids. When you have our behaviors as grandparents, totally different, right? What's the continuum? But it's different. The piecewise, right? The mathematics, normally most of the people believe the mathematics is a hard subject, but mathematics is very simple. This each and every term applicable to our real life. Right? Each and every point is applicable to our real life, right? There's no time to discuss those parts, right? So if you have time, we can discuss, right? Later. Now this question say, now it's depend on the tickets of the soup, right? Now they expected to write the cost function, cost function. I consider it as C. Depends on number of people, right? Depends on number of people with the variable is x. Now we want to write the cx function. It's a piecewise function. Right? Normal piecewise function we write the function f. How these functions behave in the different x values. When x in between this region is like this, the x is between this region is like this, the x is beyond that like this. This is the piecewise function, right? So now x is the number of people. Now it's considered the 3 places. If the visitors 1 to 9, the one ticket is, if 1 to 9, the one ticket is $13. Then people group is 10 to 20, its cost is 12. When it's more than 21, all set get $250. If the people get more than 21, the fixed value, flat rate is 20, so $250. It's not depend on the number of people. You consider if we are with the soup with the 30 people, it's a flat rate, 250. It's not depend on the number of people, 250 times X, right? It's not like that. Now we are write the cost function from this bracket. Now X is the number of people. Now people in between 9 and 1, what's the cost? Now I am going to see the zoo with my 5 friends, including me 6. Now it's a 6 times X. I have to pay 6 times 13. So 6, we can call 13X. X is number of people in between 1 and 9. Then X between 10 and 20, what's the cost of ticket? Is 12, should multiply by number of people, 12X. When X greater than or equal to 21 is not depending the number of people, it's a flat rate, 250. It's a fact. ඒක වෙනස් වෙන්නේ නැහැ. 21ක් ගියත් එකයි 30ක් ගියත් එකයි 100ක් ගියත් එකයි අනන්තයක් ගියත් එකයි 250 ගෙවන්න. Right? This is the final answer of question 4. Piecewise function of the cost depend with people. The X variable X is number of people. Number of people. Right? You got it? Yes. If you have any doubts or need more clarifications, please ask, right? According to time, we can recheck those, okay? The next one, the drug case, right? I'm not going for the paragraph explained. It's for the drugs to have the beneficial effects, concentrates in the bloodstream must exceed a certain value called the minimum therapeutic level. Right? Therapeutic level. Suppose that the concentration C of the drugs 3 hours after it's taken, there will be a drugs with time, right? Drugs level of the time t is given by this function. 20t t square plus 4. There will be a unit, right? This is the drugs at time t. Right? The minimum level they say it is 4 milligram per liter. There should be the minimum is 4 milligram per liter. Determine when this level exceed. When this level exceed, the minimum is 4. When this exceed mean, and which time it's become to lower. The minimum exceed of the minimum mean, this is the minimum. The minimum. අවම මෙච්චරක් තියෙනවා. මේ වැඩි වෙන පැත්ත ගැටලුවක් නැහැ නේ. Then exceed mean at which time it's maybe go down from 4. Exceed of the minimum. Right? So how we find that one? First we need to check at which time it reached the 4. At which time it's reached to 4. Therefore, the unit of this equation is milligram per liter. The units are same. Equal this left side, so right side of this formula to 4. The 4 equal. Now we want to check at which time this function reached to 4, level 4, flux level 4. 4 equal 20t, t square plus 4. This is a quadratic equation. Solve this quadratic equation for find the t value t. 4 times t square plus 4 equal 20t. First multiply. 4t square plus 16 plus 20, sorry, equal 20t. Again quadratic, right? 4t square minus 20t, bring this 22 to this side, plus 16 equal 0. Right? Equal 0. Yes. Yeah, this can be, yes, this is inequality. This, or we can write like this. 4 less, there's a minimum. No? Yeah, that's the minimum, like this. At the end of the final value for t, finally we need to check the regions. And then we can say at which time this exceed the minimum level. Yes, that's good, right? This is also the inequality. But I think this is the very easiest way. By equaling the minimum value, we can find the t at which time this level goes to 4. After finding the time for level 4, we can check beyond that regions and what happened for this inequality. Right? Yes. We can go for this inequality also. Right? Now I got the, so whatever the things we do, we have to find the value for t. Whether it's inequality or the equality, we should solve this equation for t. Now that's one is I am going to do here. Now zeros of t. So solve the this quadratic equation. The focus the coefficient of t squared and constant. By considering these two, check the can we create the middle term? Yes, easily we can create 16 plus 4 is 20. So we can do like this 4t squared minus 4t minus 16t plus 16 equals 0. Take the common factor of first two part is 40. Then the common factor of rest part is 16 minus 16, t minus 1 equals 0. Then t squared minus 1. No, yes, t. Yes, not t squared, t. T minus 1 is common factor of this equation. Then rest is 40 minus 16 equals 0. T equal 1, no. 40, we can write t squared minus 1 equals 0. 40 minus 16 equals 0. From this one, it get t equal 1, no. This t equal 4. Right? Now, at the t equal 1, it can be reached to minimum level, right? When you substitute t equal 1 to here, the existing drug level is 4. At t equal 1, it is the reached the minimum, right? Now we can work this as a inequalities. Our t is 1 and t equal 4. 1, 4. And which level it exceed 4. අවම 4ක් තියෙන්න ඕන ඊට අඩු වෙන්න බෑනේ. එහෙනම් at which level it reach to below 4? One is the given point. Right? 1 is the given point. Check at 4. At what happened for C equal for T equal 4? 20 times 4, 4 squared plus 4 equal what? Can you find the value of this? It's 80 divided by 16, 20. It's also 4. Now in between here, in between 1 and 4, and 1 to minus infinity, then 4 to plus infinity, right? Check the point is here. My test point is t equal 5. T equal 5. At what happened? When t become 5, C5 equal 20 times 5 divided by 25 plus 4 is 100 divided by 29. 100 divided by 29 is 3.4 sum. 3.4 sum. Right? When t equals 0, C0 what happened? 0 divided by 4. 0. Right? In between 1 and 4, there exists a level. So other way, level exists. So time is should be positive, no? Right? There's no negative times, right? So after 4 hours, the level is exists. The level is exceed t greater than 4. T greater than 4 hours. Right? T greater than 4 hours. Level exceed. Right? When I go for the inequalities, what we write here? Similar way, we have to find the zeros of t. When I write it as inequality, we have to find the zeros of t. We should solve this inequality. Sorry. We should solve the quadratic equation. The same values you get 1 and 4. Same value you may get the 1 and 4. Check in between the region, right? After 4 hours, the minimum level get down, right? Right? Then section number 6. Section number 6. Sketch the graph of a plot a graph x plus 2 plus 3. Right? Do you know which type of the graph of square root x? Then y equal square root x is look like what? Right? Most important things they ask domain and the range. Domain and the range. The domain means which are the we can get for x. Range is where we can find the fx. According to my personal view, right, this beyond this assignment, I strongly believe most important term on our real life, not only maths, right? Maths is also, the domain is very important term. Domain is very among the mathematics, even our real life, right? If we know our domain, we can do what is the perfect things. If we don't know about the domain, we do the wrong things, right? As example, in our school level, our domain is school as a school student. Our domain is school student. We have some boundaries. The domain says this has some boundaries, right? We cannot do something outside. We should behave like a school students in our domain. We can see some news. They are doing the things not shoot on this domain. That's why it's become as a news. The bad things. Right? If you are considering our domain perfectly, we know what are the things we have to do. Right? What are the things we have to do? Right? What are the things? The person who knows the maths, he will already know what is the domain and he already know what are the things he and she should do. Right? So therefore, I consider this domain is a very important terms on the maths and right? When you consider the square root text function, we can find the values. The function is like this: x, y, x, y. When x equals 0 is 0, it's a positive side. When x become 1, it's a 1. 0 is 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1. When x equal to square root 2 is equal 1.4 something. No? Into x equal 3 or something. X equal 4 is 2. 4 is 2. The functions is look like this. Square root is a plus side because each and every time x should be greater than or equal 0. The things inside the square root should be positive. Now our part is x plus 2 square root x plus 2. Shall we check some values here? X fx. Then we can draw the graph like this. The inside should be the positive. What is the minimum x value we can get here? It means range. Now we are talking about domain. What is the minimum x value we can get for satisfy the things positive inside the square root? Make it positive and x value at least one student. What is the minimum value we can get for x? Yes, good. When x equal minus 2, x equal minus 2, this part is 0, value is 3. 1, 2, 1, 2, 3, x, y. 1, 2, 3, this is minus 2. When x equal minus 2, y is 3. Y is 3. Now can x minus 1? Yes, x can be minus 1. When x equal minus 1, it's become 4. Then 0 Square root 2 plus 3. Square root 2 is 1.3 and 3.47 or 4.4. What's the domain? X can be minus 2 up to infinity. The domain is minus 2 to infinity. Are you clear that? X can be minus 2 to infinity. Right? Now, when x equal 1, square root 3 plus 3. And now here, there's a graph function like this. This is the function of, this is the graph of fx. Now, this one is the graph of square root x. Now, this is the graph of fx in our section square root x plus 2 plus 3. Right? Our domain is minus 2 into infinity. Minus 2 is close, right? We can use minus 2 up to infinity. Now, where is our domain? Sorry, range. Where the y value is? Our range is 3 to infinity. 3 up to here. 3 to infinity. 3 domain, range. Domain is minus 2 to this side. Right? This is the domain. This is the range. Right? Then the question asks, is this one-to-one function? Is this one-to-one function? I write function is here. The graph is here. This is a graph of square root x plus 2 plus 3. Is it one-to-one? What means one-to-one? Domain, codomain, the one point of the domain match with one point of the codomain. The one point of the domain match with one point of here. One of here, one of here, one of here, one of here. Ekateka. Like Asian countries, lawful marriage, right? Asian countries, lawful marriage, right? Over the law, they can, right? But according to our law, one man can marry the one woman, right? One-to-one function, right? So how we check the function is one-to-one? There be abstract way. Fx1 equal fx2. Finally, we should show x1 equal x2. This is abstract way, the proof. Or otherwise, which type of test are they have for checking function is one-to-one? Function is one-to-one. Horizontal test or vertical test? Horizontal test. Yes. Horizontal. Draw a horizontal line. If function is cross at one point of the one horizontal line, we call it is one-to-one. According to the, by horizontal test, we can say function is one-to-one. If so, it means if yes, what is the inverse function? Inverse function exists only on inverse function exists only on one-to-one functions. Inverse exists only on one-to-one. If function is not one-to-one, there's no inverse. Right? One father, two mothers, two kids. So which one is which kid consider is my father? The inverse is not exist. Function exists, but inverse is not exist. That's the conflict. Yes. Can you use x1 equal x2? Yes, you can use. Right? You can use x1 equal x2 methods. Right? For checking the one. This is a one function, so inverse exists. So how do you find the inverse of fx? I think this may be the last one, right? Fx equal x plus 2 plus 3. For inverse, shift now. The fx I equal y, right? Y equal x plus 2, right? So what we have to do for the inverse, first step, we switch the terms. Now we switch terms. X equal y plus 2 plus 3. Now we should solve this one up to y. We should subject y. I bring 3 to this side, x minus 3 equal square root y plus 2. Then square both sides, x minus 3 square equal y plus 2. X squared minus 6x plus 9 equal y plus 2. So y equal, bring this 2 to here, x squared minus 6x plus 7. This is the inverse function, right? This is the inverse function, right? This is the inverse function of question number 6. Right? That's the question number 6. So now it's close to learn, right? So what to do? We have 2 questions, 7 and 8. Okay, 7 is case the graph and determine the domain range, and are they having asymptotes? Right? Are they having asymptotes? Okay, we'll discuss this rest of 2 in another time, or I will upload the answers to the levels, right? Okay. You can try 7 and 8, right? 7 is just how to draw the exponential graph, 2 to the power x term graph, right? You can easily find substituting the value for x, right? Then gx equal 2 to the power x minus 1 plus 3. Then you can write the table x and gx when x equal 0, what happened? Half plus 3. Then x equal 1, 2 to the power 0 plus 3. Like this, you can draw the graph. That graph running through over the 3. This is asymptote, right? This roughly sketch, right? Then the 8th one, it's asked, they are being given the population function. Population function pt equal 1000 over 10 plus 9 e to the power minus t. The decay population graph. First one is calculate the approximate population after 3 years. When t equal 3, find the value of pt. Right? When t equal 3. Then find the inverse. The inverse function you should find, right? Inverse function. For inverse, what we have to do, we shift the variable, shift the terms, right? Shift the term. That means here is t. we have to find the inverse function. Right. Here's t 1010 plus 9 e to the power minus pt. Right. The inverse functions. We have to find the pt. Oh, yes. Without safety node, you can find, right? We have to find the pt. Right. I write inverse function here for your understanding. T equals do you have time at least? Thank you, sir. Today discussion was very useful. Thank you very much. Right. Okay. We will do asymptote mean, right? The function not exist on the line. As example, consider x and y. Asymptote mean on that line function is not exist. As example, you can see e to the power ex function is like going on like this. This is the asymptote. Then this graph goes to very close on this x line, but is not reached to x. We call this is asymptote. The function is not exit from the line. Sometimes you may see this type of. This is x equal 1. The graph like this. Functions go close to this line, but is not on the line. We call that this is asymptote. Function reach to the line, but not on the line. The simplify, we can say the function is not exist on the line. Function is not exist on the line. Right? This is the asymptote. Okay. Okay. This time is finished, right? So yes. Okay, as in future there will be more discussion classes, right? We can see and discuss whatever the things you have in doubt, right? Okay, so thank you very much. This is the first lecture when I came to Sri Lanka from Australia, right? This is the first lecture I'm doing here. Thank you very much for your comments. Okay, see you soon. Okay, right. Thank you very much.